Welcome to Maths for All. I'm Aisling Flynn. This is the line 1.3, distance or length. So we're going to go through this by answering a question. C is the point 3, 1, D is the point 10, 4. Find CD, the distance between these 2 points. So notice there the use of these parallel lines to indicate distance or length. So the length of the line from C to D is the same as the distance between the 2 points, or the size of. So you've seen these parallel lines used before when you did the modulus in complex numbers. It means the size of, the length of, or the distance. So we're going to start by graphing the 2 points C and D on the coordinate plane, and you can see them there. In the next diagram we join C to D, and you can see the line segment CD, and that's what we're looking for. We're looking for the length of that black line. On the next graph, what I've done is I've created a right angle triangle by going horizontally from C until I am directly under D, and then I've gone straight up. So we did something like this when we looked at slope. You're getting like a run and a rise. Okay, you're also getting the difference between the horizontal or x coordinates along the bottom, and you're getting the difference along the side of the y coordinates, or the vertical coordinates. Okay, now hopefully you'll start to recognize this as a right angle triangle, and that maybe we can use it to find the length between C and D, which I've labeled C here. Okay, you'll see why in just a moment. So now we have our right angle triangle, and hopefully you'll recognize it as such, and that we can now use Pythagoras Theorem to find unknown sides. And C was labeled such here because it refers to the hypotenuse in Pythagoras Theorem, which is the longest side of the triangle opposite the longest or the largest angle, which is 90 degrees, and then the other 2 sides are called A and B. So here we have Pythagoras Theorem, C squared equals A squared plus B squared. So we're looking to find C, the hypotenuse of this triangle. What is A and what is B? So looking at A, well, A goes from an x value of 3 horizontally to an x value of 10. So 3 up to 10 gives us a value of 7. So the bottom of that triangle there is 7 units long. And for B, we're starting at a y value of 1, and we're going up as far as 4. So that gives me, 3 units. You can just count the boxes up, 1, 2, 3. Okay. So substituting those into Pythagoras Theorem, here we are. We have C squared equals 7 squared plus 3 squared. And working that out, we get 49 plus 9. So C squared equals 58. And that means that C is equal to the square root of 58. So in geometry, we most often leave it as that, unless we're asked to convert it to decimals, which means that C is approximately equal to 7.62, and the question would tell you how many decimal places you should include. Okay, so we found out that the distance from C to D, or the length of the line segment CD, equals square root of 58 units. So just over 7.5 units. Okay, so that's using a graph, counting, and using Pythagoras Theorem. Alternatively, we do have a formula in the formula and tables book for distance, and this is it here. It's the square root of, so in the first bracket we have x2 minus x1. Now that's just the horizontal distance from one point to another. That was our A. So it's the same thing essentially, and square it, and then plus y2 minus y1, well, that's the difference in the y values, or the vertical difference. That was our b, and it had to be squared, and then to get the distance, the square root of the sum of those. So this is just an alternative representation of Pythagoras' theorem, but you can use it straight off when you have the coordinates, for example, if you didn't have the graph shown. So this is how we do that. Remember, our c was 3, 1, so that's my x1, y1, and d was 10, 4, so that's my x2, y2. So substituting that into the distance formula, so x2 is 10, subtract x1 from c is 3, plus y2 from d was 4, and y1 from c was 1. Okay, so substituting, then we work out the inside of the brackets, and it starts to look just like above almost. We get 7 squared plus 3 squared, which is 49 plus 9, and we will get the square root of that afterwards. We get the square root of 58, which is the same. Okay, so depending on what question you have in front of you, if you're working on a graph, or if you just have coordinates and you want to get quickly to the answer, you could use the formula also. Okay, and let's take a look at the formula book, page 18. It's the coordinate geometry page. We're looking at the line. It's not slope, but it is the length of a line PQ. So it's called length here, not distance. And here you see that the length of PQ is equal to that. There's your distance formula. Okay, let's practice it. The points A, B, C, D are shown. Find the length of AB. So the length of AB. So how long is it from there to there? Okay, so what I'm going to do is I'm going to stick, because we have a graph, I'm going to stick to Pythagoras. Okay, I'm going to make a right angle triangle. I'm going to count the units from A to B across. 1, 2, 3, 4, 5, and 1, 2, 3. Okay, and we're looking for this C. Remember, Pythagoras has c squared equals a squared plus b squared. So the length of AB we'll get by saying that AB squared, which is my hypotenuse, equals to 5 squared plus 3 squared. Okay, AB squared is equal to 25 plus 9. AB squared is equal to 34, and so AB is equal to the square root of 34. Okay, and so we'll just repeat that for the other questions. So A to C. All right, so this is orientated a little differently. I'm going to draw go from left to right. I'm going to draw horizontal from C. So it's a very narrow but very tall triangle. So this will be A and this will be B. Okay, and A is just 1 unit across, and B is 1, 2, 3, 4, 5, 6, 7. B is 7 units up. Okay, so 1 and 7 are my A and B here. So I get AC squared equals 1 squared plus 7 squared. AC squared is 1 plus 49. So AC squared is 50, and AC will be the square root of 50. Now incidentally, if you put in the square root of 50 into your calculator, what you get back is 5 root 2. And that's correct also. Why 5 root 2? Because 50 is 25 times 2, and the square root of 25 is 5, which comes outside. You're left with the square root of 2 under the square root sign. Okay, and finally A to D in this part of the question. So going from D horizontally and then up here. Okay, and your graphs are your own in an exam. You can scribble as much as you like on them. So horizontally we have 1, 2, 3, 4, 5, 6, 7 units, and we're going up 2, 7 and 2 for A and B. Okay, and next we will square those numbers. 49 plus 4, AD squared is 53, and AD will be the square root of 53. Okay, so we've done parts 1, 2 and 3. Now question, is DC equal to BC? Right, so now we've two more distances to calculate. So D to C is here. So we want to create a right angle triangle. If I go from left to right, I'm going across the top here, D until I'm in line with C, and then down. So here's my right angle triangle, and I'm 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5 down. Okay, so DC will be 6 squared, or squared. DC squared will be 6 squared plus 5 squared, which is 36 plus 25, which is 61. And so DC is the square root of 61. Now, part of the same question is DC equal to BC, so we have to calculate B to C. Okay, there's B to C, and here's a right angle triangle created there. Now let's count from C across to B is 1, 2, 3, 4, 5, 6, and up from C up to B is 1, 2, 3, 4. So straight away I know they are not going to be the same, but let's show the calculation. B to C will be 6 squared plus 4 squared. So we get 36 plus 16, which gives me 52, and BC is the square root of 52. So we have to answer the question that is asked. Is BDC equal to BC? Now we can say no. That's answer. So yes, no answer. Or we can write DC is not equal to BC. And why? Well, quite clearly, the square root of 61 is not equal to the square root of 52. Okay, so here's another example. It's more of an exam type question. Okay, but you must remember that everything you've learned thus far still applies. So let's have a read of it. A, which is 3, 5, and B, which is 7k, are 2 points. So that's what's different here. We're working with a variable, an unknown number, okay, but our theory will still be the same. If the length AB, so the straight lines are used there, the parallel straight lines, you need to recognize them and know what they mean. So if the length of AB, or the distance between AB, is equal to 5, find two possible values for k. So we expect to get two answers. What do your solutions look like on a graph? So we'll figure that out later. So firstly, we're going to use the distance formula. Okay, so perhaps we should have written that down first. So the distance formula, straight from your logbook or your formula tables book, says that the distance PQ is equal to x2 minus x1 to be squared plus y2 minus y1 to be squared, and we get the square root of that answer. Okay, so in this case, point A is being used as x1, y1, and point B is being used as x2, y2. So we're going to substitute into the formula. Now firstly, we know the answer for the distance, which is 5, so we start with 5 equals. Okay, then square root. x2 comes from B, that's the 7, minus x1 comes from A, that's the 3, plus y2 comes from B. So this is where people get confused and stopped, but proceed with what you know. Put in k instead of y2 and we'll figure out what happens after that. And y1 is 5. So we've substituted correctly into the distance formula. Now we're going to work with it as best we can and see, can we figure out what k is. It is the only unknown variable in the equation now, so it should be possible to solve. Now, so here we have workings out of what's underneath the square root. Okay, I think I'll need to do some rough work here. Alright, so firstly 7 minus 3 is 4, so there we have 4 squared. That's the first bracket. Now where did all this next part come from? It came from k minus 5. Had to be squared. K minus 5 was to be squared. That means k minus 5 needed to be multiplied by itself. Okay, so now let's do that. K times k is k squared. K times minus 5 is minus 5k. Minus 5k by k is minus 5. Okay, and then minus 5 by minus 5 is plus 25. So when you put these two middle parts together, you get minus 10k. And that's where those three terms come from here. So maybe get a piece of paper yourself, pause the video and see, can you come to the same stage as this. Alright, what happens here? Well, 4 squared is 16. That's the only change there on that line. Okay, on the next line, 16 and 25 are combined. They're both numbers to give 41. 16 and 25 give 41. Okay, now does this under the square root sign, does it look a little bit familiar? It's starting to look a bit like a quadratic equation to me. Okay, but the problem being is we have a square root sign. So how do we get rid of that? Well, we're going to square both sides. Remember the golden rule? You can do what you like to an equation once you do the same to the left and the right. Okay, to keep left equals right. So we're going to square both sides is what happens here. Square both sides. Now when you square a square root, it just tends to disappear. Alright. Or it does the opposite, it undoes it. Okay, and when you square 5, you get 25 down here. Okay, so that's where that comes from. Next, as I said, it's starting to look like a quadratic, but we've always solved quadratic equations with the three terms equals to 0 on the other side of the equation. So that's what we're going to do next. We're going to take 25 from the left and also the right, and then we get this next line. Tidying that up, 41 minus 25 gives this 16, and the three terms are equal to 0. So now we have a quadratic equation. How do we solve quadratic equations? Well, we have two choices. We can factorize, or we can use the minus b formula. So your preference. I'm factorizing here. Okay, so the factors of k squared are k and k. K times k. The factors of 16, I've chosen 8 and 2 gives 16. We need them to add so that they give minus 10k, so I'm using minus 8 and minus 2 together will give minus 10, while multiplying to give plus 16. So you can pause the video at this stage also and work out the factorizing there as you would normally and make sure that you get the same answer. Now the next step to solving that is to put each factor equal to 0. So k minus 8 equals 0. When you solve there, you get k equals 8. The other option there is k minus 2 equals 0. When you solve that, you get k equals to 2. So we found our two possible values for k. Alright, so just a note, you can't use a negative answer for distance ever, because you working with square roots, it won't work. Okay, so point B is either 7, 8 So when we're using this one, or 7, 2. All right, we're asked to show these solutions on a graph. Okay, so firstly, that's 3, 5, that's point A. Okay, and the two possible B's are, that's 7, 8 up here, and 7, 2 down here. Okay, and the distances between those should both be 5. 5 and 5. All right. So now it's time for you to do it. Try the quiz, distance or length, and the written exercises.